2 we are going to revise. So in this we have pre-board portion. I'll just say you about what is a mixture, types of mixtures. Then we have about what is a solution alloy, and we have the concentration of a solution, and what is colloidal solution, what is suspension you have. Learn all the properties of a colloid and etc. Remember this one, this is very important thing. Next is all is not there, but in the term and examinations um they asked this one. Okay, they asked about this, about what is this called. And next, sorry, they have asked this and that. You have to learn this type of tables. Next it is physical and chemical changes. What are the types of pure substances, elements and compounds? This is the thing, this is the differentiation. Fine, so let's go with the starting page onwards and understand everything from the beginning. So we're gonna cover 3 chapters today, and we have a lot of time includingly. So yeah, let's start. How do we judge whether milk, ghee, butter, salt, spices, mineral water, or juice that we buy from market are pure? Have you ever noticed the word pure written on the packets of these consumables? For a common person, pure means, what does a pure means? Having no. Common person, pure means having no adulteration. But for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is actually a mixture of water, fat, proteins, etc. When a scientist says that something it is pure, that means all the constituent particles of that substance are in the same, they are same in their chemical nature. So generally, pure substance is different. Pure substance and mixture are two types. So pure substance is something which consists of same chemical properties of everything. Okay. So this consists of same in their chemical nature. Substance which consists substance that consists same, all the constituent particles of the substances are same. All substances substances in same, there should be same in chemical nature is said to be a pure substance. Okay, so they all it should be same in, so it consists a single type of particles, single type of particles. Clear? So in other words, a substance is pure in sheer single form of matter. As we look around, we can see the most of the matter around us exists as mixtures of two or more pure components. For example, seawater, mineral soil, etc. all are mixtures. What is a mixture? Mixture are constituted by more than one kind of pure form of matter. Mixture means mixture consists of more than one kind of matter, pure substance. Fine. So, a substance cannot be separated into other kinds of matter by any physical process. We know that the dissolved sodium chloride can be separated by water by physical process of evaporation. However, sodium chloride is itself a substance and cannot be separated by physical process into chemical constituents. Similarly, sugar is a substance because it contains only one kind of pure matter and its composition is same throughout. Soft drink and soil are not single substances. Whatever the source of substance may be, it will always have the same chemical characteristic properties. Therefore, we can say that the mixture contains more than one substance. Okay, mixture consists of more than one pure substance. Types of mixtures. So what are the types of mixtures? Now we are going to see that. Depending upon the nature of the components, the form of mixture, we can have different types of mixtures. So first is hypotonic. Sorry guys. It is homogeneous mixture. So mixtures have two types. First is homogeneous. So homogeneous mixture means um, this have a uniform composition throughout. Uniform composition throughout. Fine. So some other examples of such mixtures are salt in water, sugar in water. Okay. When they mix, we cannot see what the where is the salt is or sugar is. Okay. The examples: salt in water. Make a note of all such things. Sugar in water. Okay. So going with the next type, heterogeneous mixture. Okay. What is this? Is the opposite of the previous one. Consists of non-uniform composition. Okay. Throughout. So example here, oil and water. We can see oil differently and water differently. Clear? So now we shall learn about solution, suspension, and colloid. What is a solution? Solution is a homogeneous type, guys. So homogeneous have again types. The first type is solution. What is a solution? Solution is a homogeneous mixture of two or more substances. It is a homogeneous mixture of two or more substances. Okay. So solid solutions are alloys. Gaseous solutions such as air. Okay, this is what is homogeneous. So first type is solution. So it is a homogeneous mixture which consists of two or more things. Alloys we'll learn after solution. So solution has a solvent and solute. Now this solution have a solvent and a solute. So what are these both? Which is being dissolved and the large smaller quantity and larger quantity. Clear? So examples, you can learn the examples. So air is the first example. Example is air, which consists of many gases, right? Or you can take a solution of sugar in water. Okay. Solution of iodine. Iodine in alcohol is known as Tincture of iodine. Then it is of aerated drinks. Okay, so all are the examples, guys. You can elaborate. You know, no aerated drinks is nothing but we have soda water, this and that, all the things. So in that, what will be our solute in the liquid water? There will be carbon dioxide in a soda. So in the same way, alcohol. I mean, sorry, iodine and alcohol, air, which consists of many gases, is a prominent example. So properties of a solution is a very important. I mean, not only solution, the different types of properties of different things are very important. Coming to the properties of solution, what are the properties of a solution? It is a homogeneous mixture. First thing, it is a homogeneous mixture, right? Second thing, here they are talking about it is very small. They are very small. They are very small. And what is the size? They are less than 1 nanometer. 1 nanometer, 10 point power minus 9 meters. Clear? So it cannot be seen to characterize. Because of this very small size, because of this size, there will be Tyndall, no Tyndall effect. Okay. So the solute particles cannot be. Physical processes cannot help for the separation. Okay. The first thing is it is a homogeneous mixture. Second thing, it is very small. It is 1 nanometer. That means less than 1 nanometer is 10 power minus 9 meter in diameter. It cannot be synchronized. And due to its very small size, it produces Tyndall effect. Next, the physical processes cannot help to separate. Okay. Examples is air, aerated rings, and salt in water, iodine and alcohol, and all of this. This is called tincture of iodine. This is very important, guys. Concentration of a solution is an important thing. Let's go through that. Here you learn many terms. Okay, but before that, we'll go for alloy. Then we'll go for that. So coming with alloy, what is an alloy? What are alloys? Alloys are the mixture of two or more metals or a metal and a non-metal and cannot be separated into the components by physical methods. So mixture of what all? Two or more metals. Two or more metals or a metal and non-metal. Okay, a mixture and it cannot be by separated by physical methods. Clear? Now I'm going with the concentration of a solution. Of a solution. So we understand that the solution in the relative proportion, the solute and the solvent can be varied depending upon the amount of solute present in the solution. It can be called dilute. Okay, depending upon the amount of solute present in a solution, it can be called dilute, concentrated, or a saturated solution. Dilute and concentrated are comparative terms. Okay, so all of these terms now we'll learn, no, they come under dilute, concentration, or concentration, concentrated or saturated solution. So, at any particular temperature, a solution that has dissolved as much as solute as it is capable of dissolving is set. In other words, when no more solute can be dissolved in a given temperature is called saturated solution. First term we have learned is saturated solution. What is saturated solution? When no more solute can be dissolved in a solution is called saturated solution. Clear? So coming with next, the amount of solute present in a saturated solution. So the amount of solute present in saturated solution is its solubility. Clear? Is its solubility. If the amount of solute contained in a solution is less than the saturation level, if it is less than the saturation level, then it is unsaturated solution. Okay, so so the various ways are: first is mass of solute by mass of solution into 100. Second one is mass of solute by volume of solution into 100. Okay, coming to suspension. What is suspension? First it is heterogeneous mixture. It is a heterogeneous mixture. Then can be seen through NACDES. Then they scatter light till the particles settle. Okay, the solute particles settle down. They can be separated by physical methods. Guys, there's a format for this steps. I mean, there's a format for the properties of anything, suspension, colloid, or if you take a solution. So, what is the format? First, whether it's an homogeneous or a heterogeneous type of mixture. Then the second one is we can see it or no. Third is it is a Tyndall effect producing or no. Fourth is how can we differentiate it. I mean, we can do it in physical methods or a chemical method, or we can do it in where we have where we can separate the separating technique. Here we're gonna learn. Okay, they can be separated. Solution cannot be separated by physical method, whereas suspension can be separated. Suspension can be seen through Nagdas, but solution cannot be seen through Nagdas. Solution is very small, which actually, so yeah, they don't produce Tyndall effect. This produce Tyndall effect till the particles get settled down, and that is a homogeneous step, and this is a heterogeneous step. Separated. Clear? What is a colloidal solution? What is a colloidal solution? Coming to colloid. A colloid. Here we have to observe a word called Tyndall effect. The scattering of a light is called a Tyndall effect. So Tyndall scattering of light. Clear? So the properties, if we go on, it is a heterogeneous mixture. Second one, size of particles is too small, but but big enough to produce Tyndall effect. Okay. Fourth one, they are stable. Okay, and coming for the separation part, they cannot be separated. They can be only separated by, can be only separated by, how can be they separated? By a method called centrifugation. Centrifugation. Clear? This is the properties of a colloid. What are the properties of a colloid, guys? It's a heterogeneous mixture. The size is too small, but they're big enough to produce the Tyndall effect. They're quite stable, and they can be only separated by the method called centrifugation. Suspension, it is a heterogeneous mixture, and they're big enough, and they produce Tyndall effect till the particles get settled down. Next, if they can be separated by the physical process such as filtration. Next, coming to the solution. Solution is a homogeneous mixture. It is very small. It is around 1 nanometer, less than 1 nanometer, and 10.1 minus 9 meter in diameter. So it cannot be separated by the me- um, it cannot be separated by the physical methods such as filtration. It should be done by the chemical, I mean, heating processes, and it doesn't produce Tyndall effect because of its size. It's too small. Alloys are the mixtures of two or more metals, a metal and a non-metal also, and they cannot be separated by the physical methods. Clear? So you have learned about solute solution, right? Solute is a solvent and solute. Solute is a particle, a smaller quantity. So solvent is a larger quantity. So in a larger quantity, we put a solute. We put a solute. So next, saturated solution, when there's a final amount, when there's more solute which cannot be dissolved in the solvent, then it is called a saturated solution. So the amount of solute present over there is called solubility. And if there's no, if it is less than the saturated solution, then it is called unsaturated solution. And we have mass of a solute by the mass of the solution into 100, and mass of solute into by volume of a solute solution into 100. There are two things. Fine. Now let's come to dispersed phase and dispersed medium. Dispersed phase and dispersed medium are obviously the same as solute and solvent. So solute and solvent, right? So dispersed phase and dispersed medium. You learn the solute like component or dispersed particles. Dispersed phase is solute. Dispersed phase. Dispersed. Dispersed medium. Clear? Solute and solvent. Okay. So liquid, gas, aerosol, then this solid, gas, aerosol, then gas, liquid form. This all you have to learn with an example at least. Clear? This all are not required, but learning this is important. Okay. So liquid plus gas equals to aerosol, and it is fog. So let us write down liquid plus gas. Liquid in liquid, so we are adding a liquid in gas, then we get this type of solution is called aerosol. And we, what do we get here? So when we liquid is being added in gas, it is water vapor, fog, clouds, water vapor, and etc. Click. So next, coming to solid plus gas. So in a solid, if the gas is in the gas, if the solid is included, this is also called aerosol. So in a gas, solid is included, then that is smoke. So in a solid, this is included. Coming next, gas plus liquid. In a liquid, gas is being involved. That is called foam. You can take a shaving cream. You can take soda. You can take what aerosol rings you ring. Right? Coming to the next, it is liquid in liquid. Liquid plus liquid. What is this? Emulation. So milk. In milk, you are adding water. Next, solid in liquid. In liquid, you are adding a solid, that is called mud. Okay, in liquid, you are adding mud, right? So coming to next, gas plus solid. So in solid, you are adding gas. This is also called foam. And what is an example in solid? You are adding gas, right? So you can write foam also here. Foam is an example and foam is a type. Liquid in solid, liquid in solid. Then in solid, you're adding a liquid, right? Gel. So there are many examples for this: jelly, cheese, butter. Yeah. So when you add a solid plus solid, then that will be solid sol. And here you're talking about the gems stone. Colored gemstones will be, solid and solid you're adding there. Okay. So this is what solid plus solid, solid sol, and liquid plus liquid. All such things. Fine. Liquid plus liquid, emulation, all the examples. Physical and chemical changes. These are the physically and chemically happening changes. A very simple thing. What are the types of pure substances? Till now, we learned about the types of mixture. Now, we learn about the types of pure substances. Clear. First is elements. Now, what is this elements? So, elements, this can be actually divided. It is a basic form of matter that cannot be broken down into simpler substances. Cannot be broken down into. Clear, it cannot be broken down into simpler substances. So elements are first is metals, non-metals, and metalloids. Okay, metals we have many, non-metals we have many. These are ductile, these are luster, these are having malleability, ductility, and many things. Metalloids are different, they're the different category. Fine, so you can write about all of such things, right? So metalloids is something which consists of boron, silicon are the examples. Whereas non-metals, you can take phosphorus is a non-metal. No, I think. Okay, fine. So, which consists of metal and non-metal. Combination of metal and non-metal is metalloid. Clear, metalloid is a combination. Fine. So, non-metals, hydrogen, oxygen, all such things are the non-metals. But coming to metals, you can take iron, gold, copper, all such things are the non-metals definition. I mean examples, right? Coming to compound, what is a compound? Compound is a you can say it is a combination of two or more elements. Combination of elements. Clear? It's an elements combination which is chemically bounded together. Clear, guys? So mixtures and elements compounds are the two types. Mixtures means what? Elements means what? The difference is given in your book. Mixtures means they are the separate things, they are the non-pure things. Where elements react to form new compounds. Here elements of compounds just mix together to form a mixture and new compound. Here new elements guys in compounds when elements mix together, when elements combine together, new thing is being formed. A plus B is forming C. Here A and B are the elements. C is a new compound. It is not there. It is not at all, related to the A and B. Neither, but it formed. Okay, new substance, new compound is forming here. Okay, so when we add element A and element B together, A plus B, then we get compound C. ठीक है तो अभी compound C क्या है एक new compound है newly introduced compound. So it is a newly element when elements combine together, new compound form. Compound form. Clear, guys? So mixtures. Elements are compounds just mixed together to form a mixture. Here they mix together. But what happens? Here no new substance is formed. No new substance is being formed. Clear? No new substance is being formed. Clear? Going with the second part, what our second part is saying? It does have variable composition, but it has fixed composition. Variable, but it doesn't have a stable composition, guys. Mixture doesn't have a stable composition, but compounds have a fixed composition. Fixed composition. Clear, guys? So coming to, it have the same character. Now for example, I can say you very good examples, guys. See, now you can see some parents, parent A, parent B. So their baby, whatever the child is, this child, some of the parents child will be same like them, exactly like them. So what is happening, they show their properties of their parents. Okay, they show the properties of their parents. For example, A is a mother and B is a father. So A and B have a child called C. AB. AB is a child of A and B. Now, AB show the characteristics of A plus B. That means, sorry, A and B. Those are, for example, they look white. He also look white. The character is also same of the same like his parents. So what is happening here? He's showing the same characters. He's not a different thing, right? He's not being a different person. And here it is mixing. They both are forming a new baby, and but here no new baby is formed because of the same characteristics. Okay, and this person have variable composition. Clear? So are you understanding? A and B are the mother and father. They have a child AB. AB shows the same characteristics as his parents. Take it. So what is this? This is a mixture. Coming to a compound, A and B as the parents again, and here there's a new child produced, C. C doesn't show the characteristics of their parents. It's totally different. He have the totally different properties. And here what is happening? A and B are producing a new child, a new completely different child. This is compound example. Elements react to form न्यू कंपाउंड्स जिसमें खुद ही कैरेक्टरिस्टिक्स एलिमेंट्स की कंपाउंड्स में दिखा नहीं देते, पर they have the fixed substance, they have a fixed composition. जब मिक्सचर्स में आते हैं, मिक्सचर्स में भी एलिमेंट्स और कंपाउंड्स मिक्स होते हैं, but there's no new compound formed. previous compound की characteristics ही दिखाते हैं, और इसमें क्या है, variable composition is there here. So in this, the physical methods they can be separated, but here no electrochemical or chemical methods are required to separate. Clear, guys? I hope you all have understood this one. That's it. So just check out with this table, very important table, जिसमें आप देख सकते हो कि मैटर किसमें कितनी तरह डिवाइड हुई है. प्योर सब्सटेंस में डिवाइड हुई है, मिक्सचर्स में डिवाइड हुई है. प्योर सब्सटेंस में क्या क्या है, हमें एलिमेंट्स है, कंपाउंड्स है. मिक्सचर्स में होमोजीनियस हेट्रोजीनियस, होमोजीनियस में सॉल्यूशन एलॉय, हेट्रोजीनियस में सस्पेंशन कोलॉइड. ठीक है, क्लियर गाइस? इसमें और एक्स्ट्रा कुछ भी पढ़ा है, आप फिजिकल और केमिकल चेंजेस के बारे में पढ़ा है, पर वो कम अंडर दिस ऑल ओनली, राइट? सो एक्स्ट्रा थिंग्स आर नॉट देयर एंड वेरी शॉर्ट लेसन डिलीटेड इज आल्सो देयर. सो you, I hope that you can prepare well for this chapter. Fine. So only thing you have to learn is types of colloids. Clear? Now let's go with the next chapter, atoms and molecules, जिसमें आप very easy chapter. ठीक है? Now let's go back with our atoms and molecules. Just a second, guys. I'll open the PDF so that we'll start doing that. It's a very easy chapter. I'll just revise. This lesson we have not yet revised previously. That's why I have gone line by line, line by line, line by line. पर इस लेसन में हम वैसे नहीं जाएंगे, क्योंकि ये लेसन हम ऑलरेडी रिवाइज कर चुके हैं. Yes, do you remember, guys? Did we revise it? Yes, do we did? Clear? So yeah, first thing, आपको तीन चीजें रिमेम्बर होनी चाहिए. पहला है महर्षि कनन के बारे में, पकुड़ा का जायमा, डेमोक्रेटिस ल्यूकिपस के बारे में आपको पहला इंट्रोडक्शन में रिमाइंड करना चाहिए. यू हैव टू रिमेंबर अबाउट ऑल ऑफ दिस थ्री पीपल. व्हाट डिड दिस थ्री पीपल डिड? महर्षि कनन क्या बोला आपको? क्या बोला कि हम when we start dividing the matter, we should get smaller and smaller particles. So when I start dividing particular matter, we will get smaller and smaller particles from that. But ultimately, a stage will come when they cannot divide further, and this he named as Parmanu. Parmanu is an Indian word of atoms first discovered by a Indian people in around 500 BC before Christ. ठीक है. अभी नेक्स्ट इंडियन फिलोसोफर कौन है? अकूड़ा कत्यायमा. ये क्या कह रहा है कि दिस पार्टिकल्स नॉर्मली एग्जिस्ट इन अ कंबाइंड फॉर्म व्हिच गिव्स अस वेरियस फॉर्म्स ऑफ मैटर. अभी हमारी एक ही फॉर्म ऑफ मैटर है नहीं ना, हमें डिफरेंट टाइप्स ऑफ मैटर है. तो what did this परमाणु particles do? They normally exist in a combined form. They will be in a combined form and form new matters, new form of matter. ठीक है. पहला पकुड़ा कट्यायमा महर्षि कनन के बारे में पढ़ा है, महर्षि कनन. और दूसरा पकुड़ा कनन और पकुड़ा कट्यायमा के बारे में नेक्स्ट पढ़ा है. Coming to next is a Democritus and Leucippus. तो Democritus क्या किया, Leucippus क्या किया? ये दोनों एक ग्रीक फिलोसोफर्स है, पकुड़ा कत्यायमा और महर्षि कनन हमारी इंडियन फिलोसोफर्स है. जस्ट रिमेंबर दिस थिंग. तो इसके बाद Democritus और Leucippus. What did they say? They said the same what this both people said, but this people's only is valid, right? They said that one. ठीक है. So fine, let's do it. So what does Democritus and Leucippus say? If you go on dividing matter, stage will come and particles obtained cannot be divided further. Abhi, the same thing what Maharishi Kanan said. So Democritus called this indivisible particles atoms. So abhi Greek philosophers kya name kiya hai ise? Atoms. Clear? He named it as atoms, which means it is an indivisible particles. Clear? This much only, guys. Next, about chemical laws of chemical combination, we have two laws. This is stated by Anton L. Lavoisier and Joseph L. Prost. The first law is law of conservation of mass. This states that the mass can neither be created nor destroyed. When we mass can neither be created nor destroyed after some chemical reaction. See, for example, if there's A, if the mass of a object is A before the chemical reaction and after also it will be A, it will neither be created, not A1 will be nor A0 will be, it will be only A. Okay, mass will neither be created nor be destroyed. I'll give you the example. Next, law of constant proportion. So law of constant proportion is also called law of definite proportion. अभी ये क्या state करती है? In a chemical substance, the elements are always proposed in a always they are there in a perfect ratio. They will be in the same definite properties. They're constant and they won't even change. In a chemical reaction substance, the elements are always present in the same chemical, definite properties by mass. Clear? Okay, so it is called law of definite proportions also. Next is Dalton's atomic theory. What did this Dalton's atomic theory say? First thing is all matter is made up of very tiny particles called atoms. Second thing is matter are indivisible particles which can neither be created nor destroyed. Third thing is, what is third thing? Atoms of a given element are identical in mass and chemical properties. Atoms of different elements are different in mass and chemical properties. Atoms combine in a ratio of small whole numbers to form compounds, and a relative number and the kinds of atoms are the constant in a given compound. Relative number and the kinds of atoms are the constant in given compound. Clear, guys? So this is opposite. Third and fourth are opposite to each other, and fifth and sixth are easy. First and second also easy. Clear? Now coming to an example for law of conservation of mass. Check this one. So in a reaction, 5.3 gram of sodium carbonate reacted with 6 gram of ethonic acid. The products were 2.2 grams plus. So what did they say? 5.3 add 6. It's before reaction, before chemical reaction. Then you will get 11.3. Fine. So after reaction, what happened? 2.2 grams of carbon dioxide, 0.9 grams of water, 8.2 grams of sodium are absorbed. That means they came out of this product. So when you add all of these three also, you'll get 11.3. This is the law of conservation of mass. Coming to law of constant proportions, the hydrogen and oxygen ratio always will be 1:8 by mass. Now, for example, if they say that the what mass of oxygen, if the hydrogen is 3 grams, then what will be the oxygen be? Of course, the ratio is 1:8. So if it will be 3, then it's 8 times is 24. So the oxygen will be 24. Hope you all understood. Okay? The two types है law of conservation of mass, law of constant proportions. Clear? What is an atom? How big are atoms? And what are the modern day symbols of atoms of different elements? What is an atom? Atom is a small, it is an indivisible particle, easy definition. And the very small and different objects have different atomic structure. I mean, how big are they? That will be dependent upon them only. So we have IUPAC, IUPAC International Union, IUPAC Pure Applied Chemistry. What does it do? This approves the names of elements, approves names for of elements. Okay. So atomic mass is denoted by U. So according to according to Dalton, every element had its own mass. So this is defined as atomic mass and denoted by the U. Okay, it is denoted by letter U. Unified mass. Clear, guys? Remember the symbols. Don't forget the symbols. Then, so next, carbon 12 isotope. Carbon 12 isotope is used as the standard reference. As now I'm explaining the important points, but while reading you have to read all of those. Because why? Why? Because in the exams they'll ask like that only. They'll ask any one sentence, not all what important only. Okay. So how atoms exist? They exist in a small way. Now coming to molecule. What is a molecule? Molecule is a group of atoms together. So molecule is a group of two or more atoms which are chemically a form of group which are tightly held together. And there's some forces on that. So it have two types, elements and compounds. So molecules of an element consist. What does a molecules of element consist of? So generally, molecules of elements constitute of the same type of atoms. Molecules of elements consist of same types of atoms. Molecules of a compound consist different types of elements. Different types of elements. Because compound is made up of elements, guys. Remember the main things. ठीक है? तभी molecules किस में है? Elements में है और compounds में है. Clear? On next, what can we learn here? Diatomic molecule. What does a diatomic molecule mean? Atomicity means the number of atoms constituting a molecule is known as its atomicity. Now, argon. Argon is consist of monoatomic. That means only one. Ar only will write. He only will write. Oxygen will write O2. 2 is being represented. That is diatomic. H2, N2, sorry, C2. So these all are diatomic. 2 times. P3, P4, we write P4, tetraatomic. Okay, fourth, sulfur, S8 also we can write, polyatomic. Clear? Atomicity is this one. Ozone, O3, ozone. Okay, O2 is different, O3 is different. Clear? For example, a molecule of oxygen consists two atoms of oxygen and hence it is known as diatomic molecule. If three atoms of oxygen unite it instead of two, it will get oxygen. That is not an sorry ozone. We don't get an oxygen. Clear, guys? So Next is ion. Ion is a positive, is a charged species. It's a charged species. It consists of positive and negatively charged. Anion and cation is a positively charged, I guess, right? Yes. Positively charged is cation and negatively charged is anion. So polyatomic ion. So what is a polyatomic ion? A group of atoms carrying a charge is known as polyatomic ion. Fine. So polyatomic ion means a group of atoms constituting a charge. Fine. So you can see here P, this one SO4 2 minus is all are polyatomic ions. Clear PO4 3 minus polyatomic ions is all are polyatomic ions, group of atoms. So what all we learned? Atomicity, monoatomic, diatomic, write down guys, monoatomic, diatomic, tetraatomic and polyatomic. Diatomic, tetraatomic and polyatomic. Now we learned about polyatomic ion. Polyatomic means consists of more than sorry consists of a group of atoms. Okay. So valency is the combining capacity. Valency is learnt. We learnt about valency. So now writing a chemical formula. In this you have to remember some particular things, guys. It's not easy. Okay. You have to remember some particular things. Nitrate means N3. Then HCO3 minus is hydrogen carbonate. Ammonium NH4 plus. Okay. Hydroxide HO3 OH minus. Nitrate NO3 minus. Remember all of this. Clear? Sulfide, sulfate, sulfide. Clear? Sulfide S2 minus. Sulfide IDE, ATE, ITE. Okay. Last is ATE. ATE consists of many powers, many chocolates. 4 chocolates ATE consists. ITE consists second place and sulfide consists first place. Clear? Are you understanding, guys? Oh my god, I'm not understanding whether you're understanding or no. See, sulfide is S2 minus, sulfate, sulfite, ITE is SO3 2 minus, sulfate is SO4 2 minus, ammonium NH4 plus, hydroxide OH minus, nitrate NO3 minus, nitride N3 minus, phosphate PO4 3 minus. Okay, all are easy, guys. Just remember this, all you already know. Okay. Okay, all of these are easy. Let's do one of it. Sodium nitrate. Sodium is what? Na. Na plus 1. Nitrate is nitride, nitrate. Nitrate is NO3, right? Nitrate. NO3, NO3 minus or 2 minus. Just a second. NO3 minus, N3 minus, NO3 minus, fine. So it is NO3 minus 1. So what do you get? NaNO3, because you are removing minus 1 minus 1. Clear? Let's go with another example to understand more clarity. Calcium hydroxide. Calcium hydroxide. OH minus 1. Calcium Ca plus 1. CaOH, I guess. Sorry. Calcium is 2, right? Sorry. So CaOH2. Clear? Okay. So coming to molecular mass in formula unit mass, we just do the mass. H2O, hydrogen is 1 into 2 plus 16. Here 18U. This is molecular mass. Formula unit mass आपको लिखना है जैसे कि अभी atomic mass of Ca plus atomic mass of Cl into 2. Like that you have to write and do. So molecular mass and formula unit mass, only two things are different. Only two things are different. Only one thing is different. Sorry guys. Only the words representation. मोल कॉन्सेप्ट अभी आप वर्ड्स लिख देंगे तो वो होगी फॉर्मूला यूनिट मास, नहीं दिखेंगे तो वो होगी मॉलिक्यूलर मास. ठीक है. कमिंग टू मोल कॉन्सेप्ट भी एक इजी टॉपिक है, पर आप कुछ समझना है, आपको कुछ रिमेम्बर करना चाहिए. जो क्या है? एवोगाड्रोस नंबर, एवोगाड्रो कांस्टेंट, एवोगाड्रो number is, what is this? 6.022 into 10 to the power 22 23, 10 to the power 23. Clear? This is what is the Avogadro's number, experimentally obtained number. 1 mole is equals to how much? 6.022 into the 10 to the power 23. Okay, so while forming the formula you need to remember this, you need to remember this. Okay, you need to remember all of these things. Number of moles is n. Then this n, what? This n is Avogadro's number. Then what is this and what is this? Mass. M is mass. Mass, molar mass. Number of particles. So guys, everything you must remember. Okay, so n will be, small n will be equals to n by no. It will be equals to n equals to m by m. Clear? Clear? So that's what is this lesson about. Once again, let's read what you have learned so that we all understand again what we have learned now. So we have first, during a chemical reaction, the sum of masses of a reactants and a products remains unchanged. This is known as the law of conservation of mass. In a pure chemical compound, elements are always present in a definite proportion by mass. This is known as law of definite proportions or constant proportions. An atom is the smallest particle of the element that cannot usually exist independently and retain all its chemical properties. A molecule is the smallest particle of element or a compound capable or independent existence under ordinary conditions. It shows all the properties of a substance. The chemical formulae of a compound shows its constituent elements and the number of atoms of each combining element. Clusters of atoms that act as an ion are called polyatomic ion. They have fixed charge on them. The chemical formula of a molecular compound is determined by the valency of each element. In ionic compounds, the charge on each ion is used to determine the chemical formula of compound. Scientists use relative atomic mass scale to compare the masses of different atoms of elements. Atoms of carbon-12 isotope are assigned as the relative atomic mass of 12 and the relative masses of other atoms and combined. The Avogadro's number of 6.022 to 10 to the power 23 is defined as the number of atoms in exactly 12 grams of carbon-12. The mole is the amount of substance that consists of same number of particles there as atoms in exactly 12. The mole is an amount of substance that contains a same number of particles. Okay. Mass of 1 mole of substance is called its molar mass. Clear? All did we cover or no, guys? 1 hour, 2 chapters. What a benefit you have. 1 hour, 30 minutes up as structure of atoms. How much time will it take? If I start now, it will only take 10 minutes, I guess. That also I'm going to revise. I'm not gonna. Ismay, you have to remember two things. First thing you have to remember is this electron and proton and all such things. Next, you have to remember Thomas model and Rutherford's model things. Then you have to remember about Bohr's also, three things. Then you have to remember the division and the valency, a little it should be remembered. Atomic number, atomic mass, isotopes, and isobars. Clear? First, let's read this, then we'll understand. Many scientists contributed in revealing it was known that the electron identified by J.J. Thomson. Here, electron is being identified by J.J. Thomson. Invented the canals. Electron is E minus, proton is P plus. E. Goldstein invented the canaries and electron is invented by J.J. Thomson. Here, now the structure of atom, Thomas models of atom. What did Thomson propose? Okay, what did Thomson propose, guys? So he said that this is a positive and an atom consists of positively charged sphere and electrons embedded in it. An atom an atom consists of a positively charged sphere. अभी इसमें एक एटम है जिसमें आपको इलेक्ट्रॉन्स दिखा देती है. Thomson proposed that the model of atom to be similar to that screen was putting. The electrons in a sphere of positive charge were like currents in a sphere. So, guys, you can see this is a watermelon, and watermelon have particular seeds. अभी ये कैसे दिखा रही है कि atoms में electrons कैसे हैं, watermelon में seeds जैसे हैं, ठीक है? So, in a positively charged sphere, there are electrons in it. Clear? You can write like this. And what else point is given, guys? The negative and the positive charges are equal in magnitude, so the atom as whole is electrically Newton. The atom is neutral. Sorry, the atom is neutral because the positively charged and the negatively charged are equal. If they are equal in magnitude only, it will be neutral. Clear? First thing is an atom consists of elements. Is a positively charged sphere which consists of electrons, and it is equal, the positive and the negative charges are equal in the magnitude, so it is electrically neutral. Coming to Rutherford's model of an atom, so he selected a good foil because he wanted as thin as layer as possible. This good foil was about 100,000 atoms thick. Alpha particles are doubly charged helium ions since they have mass of 5u 4u. So you can see the following observations were made. Thomson, Rutherford. Now coming to Rutherford's model, what did this Rutherford said? He said the first as the alpha particles passed in a straight lines, moved through a straight line. Clear? Going with the second, alpha particles were deflected by small angles. Alpha particles were deflected. So alpha particles move through the straight line through the gold foil, and this alpha particles they were deflected by small angles, and ev- out of every 12,000 particles they were rebound. So there are three things which we can observe over here. The first thing is they are moving through the um, straight line and through the gold foil. So alpha particles were deflected by small angles. Out of every 12,000 particles, they observed to be rebound. So most of the space inside the atoms is empty because most of the alpha particles pass to the gold foil without getting reflected. So most of the space is inside the atom because they were moving in the straight line, and that is also through the gold foil. Very few particles were deflected from their path and indicating the positive. Very few particles were deflected, that is very small reaction. So very small fraction of an alpha particles were deflected only by 180 degrees. So there's a positively charged sphere center of an atom called the nucleus. So the electrons revolve around the nucleus in circular paths. The size of nucleus is very small compared to the size of atom. Bohr model of atom. So near certain special orbits known as discrete orbits of electrons or this all we will do it tomorrow, guys. So nothing is there. So tomorrow we will do it as we covered 1 hour 6 minutes. It's long time as we took it. Fine. So let's cover structure of atom, half of the part in the next video. But we have covered almost everything from the chapter, so not required as much as revision for that. So yeah. Okay, guys. Thank you. Please take care of yourself and bye.